Okay. All right. So we graphed using transformations. Now we're going to look at another thing. You need to make sure you're paying really close attention for what the question is asking for. It's asking for you to describe the transformations. When it asks for form, a lot of times that's what we're going to use. We'll continue to use transformations. But the other benefit of a quadratic equation written in vertex form is not only that we can use the transformations, but it tells us what the vertex is right off the bat. We can use that vertex to find the axis of symmetry really easily. It tells us which direction the graph opens, whether it opens up or it opens down, and it also gives us the width. Okay? Remember that our vertex is the h and the k value, but you just got to remember there's a sign switch on h. So if I have a quadratic that is 3x minus 2 plus 1, my vertex is at 2, 1. Switch the sign and keep the y value. If my vertex is at plus 2 plus 1, then my vertex is at negative 2, 1. Okay? Switch the x value, keep the y. So what we're going to do is we're going to focus on taking our equation in standard form, because usually it's rarely ever given in vertex form. It's usually given in standard form, or rarely do we get a quadratic in vertex form to start. So we have to take it in standard form to vertex form, doing everyone's absolute favoriteest thing of all, completing the square. It's your favorite thing to do. Completing the square. Okay. Now, again, remember that there are a couple to square. I'm going to keep it consistent to what we've been doing. Absolutely crazy, but it doesn't mean it. Okay. So, just for ease and consistency, we're going to change f of x to 0 and write our equation in form set equal to 0. Okay. What is our first step for completing the square? The 4. Good. We're going to move our constant. What's our second step for completing the square? Yeah, we want to factor out the negative 3. So negative 3, x squared, what? Minus 2x. And then let's go ahead and put our boxes here while we're at it. Now, on the right side, what do I have to remember to do because I factored out this negative 3? Multiply by negative 3. Okay? But I need to multiply by negative 3. All right? So now I need to figure out what goes in those boxes. B over 2 squared. Those boxes. So on the left, we can factor, and on the right, we can simplify. Okay, negative 4 plus negative 3 times 1 is negative 7. What is x squared minus 2x plus 1 factor to be? X minus 1 squared. Now we have a factor. So, if we were solving, we would just continue from here. We would divide by negative both sides. That's our process for solving, but we're not trying to solve, we're trying to get it in vertex form, which means I need to take this equation and I need to get it to look like this equation. So you we're going to move the 7 back over.
So be positive.
Yep. And that's f of x. F of x equals negative 3x squared plus 7. F of x equals negative 3x minus 1, 7.
Did we do what we've been doing for the past?
Nope. We're going to identify the vertex just by looking at it. We don't need to do any transformation. What? If it asks for. So, looking at vertex form, what's my vertex? Yep. 1, 7 is my, or 1, 7 is my vertex. Okay, so 1, 7. Boom, there's my vertex. Now, what direction does my graph open? Up or down? Why? Open down, so it's going to go this way. Okay, We should figure out where. So axis of symmetry. Where is my axis of symmetry? Close. It is 1, but how do we write it? So my axis of symmetry is at x equals 1. So I have this imaginary line right here that splits my graph in half. Yeah.
When we graph on the test, we actually have to write that axis.
To graph it, but it's helpful for our coming up step. So now it's asking for intercepts, x and y intercepts. All right, I'm going to delete this completing the square thing because I'm going to run out of room. Get rid of that and that and that and that. It really needs to let me like select stuff in mass to delete. So I need to find my x-intercept. I need to find my y-intercept. Let's start with x-intercepts because those take more work. What does it mean to have an x-intercept? X-intercepts are when we intercept the x-axis. All of these points have one thing in common, being that their y value is 0. So we set y equal to 0 to find our y-intercepts. Now when we're dealing with functions, it's the same idea, it's just different nomenclature. Instead of changing y to 0, we make f of x 0. Is y. Y is the output. F of x is the output. F of x is the function. So we make our function equal 0. 0 equals negative 3x minus 1 squared plus 7. How do I solve it?
Oh, parentheses for x, right?
I want to solve for x.
Oh, no. I don't know. Oh, distribute?
Nope.
Okay.
Minus 7. Let's get x by itself. Let's get the squared by itself. So I get property. What's the next step? To be by itself. You can cry, but then you buck up and keep going. So what's the next step? Divide by negative 3. So negative 7 over negative 3 equals x minus 1 squared. Now what? Okay. So when we have double negative, that becomes positive. So we have, what am I forgetting? Plus and minus. Because remember, we're solving for x-intercepts, right? We're solving for points that cross the x-axis. If my graph opens down, how many times does it touch the x-axis? 2. If I don't have the plus and minus, I'm not going to get 2. So you got to have the plus and minus. All right? Next step. Add the 1. So x equals 1 plus and minus square root of 7 over 3. That is going to be a decimal. That is fine. Find it. Yeah.
Can't we just use the equation and graph the problem?
Yeah, but it specifically wants intercepts. It's asking for intercepts, so we might as well use the intercepts, right? No. Tell me. What is 1 plus the square root of 7 over 3 and 1 minus the square root of 7 over 3? Calculators. Calculate them.
1 plus what?
This right here.
That's not helpful. Putting stars on it does not make it helpful.
What are you talking about, man?
Should have that.
It's around 2.5 and around negative 0.5.
Yeah. Which question? So my two x values are 2.5 approximately and negative 0.5 approximately. Those are rounded values. So my intercepts are 2.5, 0, and negative 0.5, 0. So here and there. Estimated values. That's fine. So we're going to graph them just in the middle a little bit for the x-intercepts. Yeah.
Why can't we, like, if we were to do this, like, actually do the thing based on the equation, why can't we just guess in the first place if we're already going to get an approximate value?
the question will ask you specific graph from transformations. You would get, I think it was like this point over here, and this one over here. And so unless you're really good at graphing, you don't know if it's 0.5, 0.6, 0.7. Close, maybe, but you need to solve for the intercepts anyway. So why do the extra work? We solve for the intercepts. All right. Now we need our y-intercept. So if x-intercepts are when y equals 0, y-intercepts are when what? X equals 0. So what do I do with my equation to get my y-intercept? X0. Change x to 0. Solve for f of 0. Negative 3, 0 minus 1, squared, plus 7. What's 0 minus 1? Negative 1. What's negative 1 squared? 1. What's 3 times 1? Or negative 3 times 1? Negative 3. What's negative 3 plus 7? 4. So my x-intercept is at 0. Sorry, y-intercept is at 0, 4. You only get one. You're only ever going to cross the y. You'll always have one y-intercept. No more, no less. One exactly. Y-intercept.
You have to stop your teacher for a second. And you get 11.2. Wait. Why is there no 11? It's not in there. That's the second one though.
It's all up in the video.
Don't forget to like and subscribe.
Put down the
Just show
notification.
that no
Hit that notification bell. Okay? Now, 5 points. How many points do I have up there? 4. I have 4 points. 1, 2, 3, 4. The fifth one. This is where our axis symmetry comes in to help us plot our 5th point. I'm missing a point on the right side.
And wouldn't it just be this one that's next to the red?
It'll be symmetrical with this point on the other side. There's my 5th point.
So we just kind of go off of the axis.
That's literally the point. Have that symmetrical relationship on both sides. These are about 1.5 away from the axis symmetry. These are 1 away, and there's my vertex. So there's my graph. Okay, with y-intercept, x-intercepts, and vertex and axis symmetry. Okay? So when it asks about identifying intercepts and using those to graph your quadratic, that's what you do. If it asks about describing transformations, using that to graph your quadratic, well then you use your transformations for Monday and Tuesday. Look at the directions. I know it's really, really hard and you never want to do it, but read the directions because they tell you what to do. Alright? It's important to read. It's necessary for success. Don't give it all up.
Wait, sorry, what?
Give me a stank
I
face.
was trying to pay attention.
Alright, so let's do it again. How do I write it into vertex form?
I forgot.
We delete one and we put it on the other side.
We don't subtract
Each
1.
side. It's the same thing.
I'm so tired.
Okay, now what?
Now we get rid of 3x squared by dividing 3 by both sides.
Factor out 3.
Factoring out 3.
Let's put our box in.
Boxes.
What else do I have to do on the right side?
Multiply by 3.
Multiply by 3. Good. Thank you. Now what? B over 2 squared. And B value. 1. What's 1 over 2 squared? 1/4. Ignore them. They're not important. I'm important.
You are. Okay.
I didn't say that. X plus 1 squared. And then what's negative 1 plus 3 times 1/4?
Where does it turn into 1/4?
Because we're factoring this to this. So the square root of 1/4 is 1/2.
1 squared is 1/2.
Negative 3 times 1/4 is 3/4, and then adding to -1 gives me -1/4.
I'm more concerned.
Okay, now get it into vertex form. Everything on one side, what is it going to be? Yeah, but if you don't show your work, you don't get credit.
That's the whole.
Got him!
That's the whole.
That's
I looked
so
at that was not
funny.
I can do it backwards.
That's so funny.
You can do it.
Laughing.
Okay, now we do.
By vertex.
Subtract 4.
Really close. Negative 1/2, 1/4. Remember, there's a sign switch there. Okay? So I've got fractions. Don't freak out. It's okay. Just plot your point close to where it's going to be. Negative 1/2, 1/4 is right around there.
Oh. What if we're like not exact?
As long as it's between the two,
Uh-huh.
you're fine. But if you plot it over here,
Okay.
Obviously.
It's wrong. Yeah.
it's wrong. As long as it's close. I'm not looking for precision. As long as your point is really close,
Precision and order.
you're good.
That's
Okay.
good.
Now, let's do our x-intercepts. What do I have to do to find my x-intercept? Make y equals 0. So I've got 0 equals 3 plus, 3 times.
Find the axis of symmetry first. I was just.
There, I found it.
Wow. So smart.
I know. That's what a college degree does. Okay? What do I do?
With the 1/4.
Now I want you to notice, where do you see this equation already on our board? We're just working backwards, so you can pick up where you left off here and go to solve.
Yay.
Or you can do it again. Okay? Keep going. Solve for x. What's next?
Divide.
Divide by 3, so I get negative 1/12 equals x plus 1/2 squared. Now what? Square root. What happens when I square root a negative? An I, meaning it's what type of number?
It's odd. It's not real.
Where can I plot a non-real number on that line?
Nowhere.
Nowhere. I can't. So how many x-intercepts will I have? None. I won't have. So my roots are non-real. When you're non-real, you have no x-intercepts. Follow-up question. Looking at our equation in vertex form, what direction is our parabola going to open? Up. So if it goes up, where does it touch the x-axis? It doesn't.
So we can just.
Yep.
That is going to open up and it's already low.
No x-intercepts.
Is that like have any significance?
It means that we have no x-intercepts. So now we go straight to our y-intercept. So what do I do for my y-intercept? 0 plus 1/2 squared plus 1/4. That's 1/2 squared. 1/4. 3 times 1/4. 3/4 plus 1/4 is. So my y-intercept is at 0, 1. Now, I said you want to have 5 points. That's best case scenario. If you don't have any x-intercepts, well, that cuts out 2 points. Fine if we don't have any x-intercepts. But I still only have 2. So the other side of the axis of symmetry, there's my 3 points. Your parabola. You got to use that axis of symmetry. Otherwise, if just 2 points, I just have a straight line. I need to have those 3 points. So I've got that U shape, I've got my y-intercept, I've got my symmetrical point, and that's good enough because I don't have any x-intercepts. Okay, so we identified our vertex, negative 1/2, 1/4. What was our axis of symmetry? X equals negative 1/2. I will take off points if you do not write x equals. It'll probably be a significant number of points relative to that question. The difference between the number, negative 1/2, and the equation x equals negative. X equals means we have a vertical line. All right, I don't have any x-intercepts. No x-intercepts. But my y-intercept was 0, 1. And again, your vertex and your intercepts have to be written as ordered. I see it most often. We'll say, well, the y-intercept is 1. No, it's not. It's 0, 1. Okay. You have to make sure that you're writing your intercepts and your vertex as, okay? Now, that's if we need to graph it and we need all of those different values, the vertex, the axis symmetry, and the intercept. We write it in vertex form information. But sometimes all we care about is the vertex and just the vertex. Okay? Normally when we're dealing with word problems, because we'll ask us to find a maximum or a minimum value. The vertexes. So there's a shortcut. If we have an equation in standard form, and all I need is the vertex, we can use our vertex formula, which is negative b over 2a, gives us the x value. X of our vertex equals negative b over 2a. I want you to notice something. What am I writing out right now? Quadratic formula. What do we call this thing inside the radical? The discriminant. The location of the vertex on the x-axis and the discriminant together gives you your x-intercept. The discriminant tells you how far away, left and right, from your vertex, your x-axis, your x-intercepts are. So it's all just different sides of the same coin. So to find the x value, we do negative b over 2a. And whenever I have an x value, if I want to find a y value, what do I do with it? If I have an x value and I want to find the y value that goes with it, what do I do with it? Say I find my x value. My x value is, I don't know, 2. What do I do to find the y value that goes with 2? That's what this means. Plug it back into your function, and that gives you the y value that goes with x equals negative b over 2a, gives you the x value. Plug it back in, y value. When we're looking at word problems, the vertex has 2 numbers, which means our vertex tells us about the scenario. 2 things about the maximum or the minimum. So the Utah Ski Club sells calendars to raise money. The profit, P, in cents, from selling X calendars is given by the equation P of X equals 360x minus x squared. What is the maximum profit the club, and how many calendars do they need to sell? So maximum means we need to find our vertex. And since that's the only thing I need, then we can just use vertex. We don't have to complete the square and write it in vertex. We can just use our vertex formula. But we have x and y. We need to make sure we're matching those up correctly. Okay? Our function is equivalent to y. Okay? Our function represents y. So P of x, does that represent the number of calendars or the profit earned? Profit. So our y value of our vertex represents maximum profit. The y value of the vertex will represent the maximum profit. The x value is our input, and that represents sales. So the x value would represent how many they need to sell in order to get the maximum profit. Okay? So looking at my equation, what's my b value? B value is attached to your linear term. So my b value is 360. What's my a value? Yeah, my a value. Close. Negative 1. Plug that in. What is negative 360 divided by 2 times negative 1? 180. So, is that 180 calendars or 180 cents earned? 180 calendars, because X represents sales. 180 calendars sold. Now, assuming they sell 180 calendars, how would I figure out how much profit they would earn? P of 180 equals 3 times 180 minus square gives me profit.
Well, yeah, it's not gonna find the test.
Now, pay really close attention. The profit is listed in cents. 32,400 pennies. How many dollars did they earn?
32,000. Okay, that's like at least 32,000
Divided by 100.
Yeah.
Yeah. Okay. $4 by selling 180 calendars.
That's actually.
That's if they sell the maximum amount.
Why is there a maximum amount? I feel like if they could buy more.
Well, what would make sense is with printing, usually it's on certain intervals. So once you go, they'll charge you a certain amount for certain intervals, and so you have to hit the next interval for the price per unit to drop. Too bad.
Check me next year.
That's nice.
I can't take this.
This is not laser
Way
printing.
easier than
I'm going into calculus. I'm going into calculus.
or advanced.
Gravity's going to kick in eventually and come back down. It'll go up, and then it'll come back down. So we want to find the maximum height. So shot straight up, find the max height. Here's our function. Okay. S of t represents what? The max height.
Why?
Okay, like ran it in for just 3 more minutes. So S of t represents my height. Is that going to be the x value or the y value? The y value, because that's the function. So that'll be the y value.
This is the max height.
Well, when we find, so the vertex would be the maximum height. Okay. If I plug in any time, that will give me the height at that time. I want to specify the max height, which means I need the vertex. So the y value of the vertex. All right, so t represents what? Time. Is that going to be my x value or my y value? X value. Okay, so what's my formula for vertex? Equals what? What's my b value? Okay, what's my a value? Good. So, find the time. Round to, 2 decimals. And time is measured in what? Seconds. Okay? Now, how do I find the maximum height? S of 4.08 negative 4.9, 4.0 squared plus 40.8. What is our maximum height? You literally have one 3 inches from your hand. You should double check your math. That's why more than one person should do it.
Exactly.
Negative 4.9 times 4.08 squared negative.
Alright.
Okay.
He said negative 4.9.
Squared.
We're done with that.
Oh, just make sure you put in the square top.
Never mind. I always do.
Approximately. Height is measured in what?
It's measured in meters.
Meters.